Shanmuga Perumal is a faculty member in the Department of Information Science and Technology, College of Engineering, Anna University, Chennai. He has more than 6 years of PG and UG teaching experience. He teaches multimedia communication and networks, mobile and pervasive computing, computer communications and networks, computer architecture, mobile computing, mobile networks, ad hoc and sensor networks, communication techniques, grid computing, programming and data structures, problem solving and C programming. He is a member in several board of exams that include IT Board of College of Engineering, Anna University, Chennai, and board examiner in CSE, Computer and Communication, MCA of National Engineering College, Tamil Nadu. He has delivered guest lectures in various engineering colleges of Tamil Nadu, including National Institute of Technical Teachers Training and Research. He has also attended faculty development programs, seminars, conferences, and workshops. He has many publications in international journals and international conferences. He has filed a patent in India and published his novel idea in the Indian Patent Journal. His research area includes wireless sensor networks, mobile communication, location-based services, and electricity power generation.
Welcome to UGC lecture series in computer science. The series of lectures cover about mobile and pervasive computing. The lecture series cover about Unit 2, that includes the wireless local area networks, personal area networks, and the standard IEEE 802.11, its architecture and its services and networks, Hyperland, Bluetooth, Wi-Fi and WiMAX. The content of today's lecture is about wireless local area network, its merits and demerits, the design goals of wireless LAN, the infrastructure and ad hoc based networks. Basically, the wireless local area networks provide the mobility and various kind of flexibility to the wireless users, but in case of the fixed local area network, the users are forced to fix it in the same location till they are accessing the service. Today we are going to learn about the merits and demerits of wireless local area network. The main goal of a wireless LAN is to replace the office cabling. In case of wired network, we can see that the entire lab is completely set up with the Ethernet cables. So, there is no such kind of greater facility and flexibility to the users, and it enables the access to the internet. As in the case of wired LAN, the users of wireless LANs, they can access the internet also. To introduce the higher flexibility for ad hoc communication, for example like group meetings, WLAN support the ad hoc based communication. So, without any infrastructure, the communication topology can easily built up. So, in case of official meetings and some conference hall meetings, the laptops can be connected together without any infrastructure. So, that kind of support is provided by the WLAN. So, as with all the standard systems, the WLAN has also its own merits and demerits. So, let us learn the merits first. Flexibility. Within the radio coverage, nodes can communicate without any restriction. In case of wired LAN, all the users or all the computers has to be connected, and but in case of the wireless LAN, all the users within the communication range, they can easily connect to the other users without any restriction. The radio waves can penetrate walls, so the senders and receivers can be placed anywhere within the range. The WLANs are using the radio communication or radio signals as the carriers. The senders and receivers can be placed anywhere within the range. Without using the cables, the users can be connected together. Planning is the major advantage of the WLAN. So, in case of wired network, we have to do all the cabling and all in very well planned manner. So, where we have to place the switches and where we have to place the hubs and other systems. So, that setup is a very major headache for building any wired local area network. But in case of WLAN, once if you built up the access point, the other users can be easily added to the network. So, any wired network needs the wiring plans, but wireless ad hoc networks allow for communication without the previous planning, as long as the devices follow the same standard. If we are adding some new wireless LANs, they follow some new standards, means we have to do some of the plannings, but the existing standard devices can be connected always. For wired network, additional cabling with the right plugs and inter-networking units have to be provided. So, we have to provide the power slots as well as the switches and hubs to provide the network facility. The next advantage of the WLAN is its compact design. So, using the WLAN signals, even tiny devices can be easily constructed. So, they are very small in size, they are very compact to carry and all. But in case of wired, it is always restricting the design of compact devices, as they are requiring the wires. And the wireless devices can be also hidden in some historical places. So, even though they will be invisible to others, they will keep on doing their own responsibilities. And next advantage of WLAN is robustness. In case of pure wired LANs, if some earthquake and all, it will happen. So, immediately all the infrastructure will be collapsed. So, we have to spend some extra time to build up all the facilities once again. But in case of wireless LANs, immediately with a short time, all the equipments, without needing the equipments, the entire communication infrastructure can be built up. So, the robustness against some natural disasters are the best advantage of the WLAN. And next advantage is cost. So, after providing the wireless access to the infrastructure via an access point for the first user, adding the additional users to the wireless network will not increase the cost. If we construct an access point for a single user, that itself can be used to continuously for adding many users. So, the cost for the infrastructure can be preserved. In case of wired LAN, you have to provide the plug point and some other network facility at every point of places where you want to provide a network facility. But in case of wireless, with the help of the access point, the users can access the network facility within the range, anywhere within the range. And also in case of wired network, the constant plugging and unplugging of devices with the network slots will reduce the lifetime of that network devices, but with the WLAN that can be easily avoided. So far we have learned about the advantages of the wireless LAN. So, the WLAN also has its own demerits or disadvantages. We will learn them one by one. Quality of service. WLANs typically offer lower quality than their wired counterparts. The main reasons for this are the lower bandwidth due to the limitations in radio transmission, the higher error rates due to the interference, and higher delay due to the extensive error correction and detection mechanism. The WLAN is providing somewhat lesser quality of services when compared with its own counterpoints in the wired LAN. So, in the wireless LANs we are using the radio waves. So, their bandwidth is somewhat limited and the bandwidth is influenced by the environment factors like multipath propagation, reflection, refraction. So, these kind of environmental factors are highly influencing the quality of the radio link. So, whenever we compare the wireless LANs, the quality of service will be somewhat lesser when compared with the wired local area network. The next major disadvantage of the wireless LAN is restrictions. So, all the wireless products have to comply with the national regulations. Just like that, we cannot use all the frequencies for our wireless devices. So, we have to get the permission from the government in various countries to use the certain kind of frequencies. So, this restriction is the major headache for building the wireless devices. And next disadvantage of the WLAN is safety and security. using the radio waves for data transmission may interfere with the other high tech equipment in the hospitals. For example, we cannot use the very high frequency signals to build up the wireless LANs in the hospitals or some research institutions, because in the research institutions and hospitals and all, we will use some high frequency radio equipments. Now, the radio signals of the WLAN may interfere with the devices. So, this will create very severe consequences. So, always we have to worry about the safety mechanisms while using the WLAN. Senders and receivers are operated by the layman. So, the radiation has to be very low. So, special precautions have to be taken to prevent the safety hazards also. And main problem is about security, as all the information is transmitted and received over air. So, certain kind of security mechanism has to be provided when we design the WLAN, or the malicious users can easily hack the information of the valid users. So, this will create a big problem in the very sensitive kind of data transmission applications. So far we have learned about the merits and demerits of the wireless local area network. Now, let us start our discussion about the design goals of the wireless LAN. The WLAN products should sell in all countries. So, national and international frequency regulations have to be considered. For example, if a wireless device is designed in US and it has to be marketed in India, now the designer should take care about the frequency ranges supported or permitted in the India, else that devices cannot be marketed in the India. So, that is a very big problem. So, what kind of frequencies are designed for that particular wireless devices, that has to be taken care well in advance. LAN equipment may be carried from one country to another country. So, the operation should still be legal in the case. The next main design goal is low power. As all the wireless devices are going to run on their own battery power, the mechanisms should be designed to conserve the power in the individual power devices. For example, even a very good wireless devices with good quality of sound and video, but if it fails to give the conservation of energy in that devices, then that cannot be marketed for a large volume of users. So, if a wireless device is consuming more power for running its application, then very soon the power level of the device will be come down. So, once the power is in very low level, immediately that node or that device will be out of the range. So, that will be isolated from the entire network. The good power conserving mechanisms has to be adapted to all the wireless devices. So, the LAN design should take care about the implementation of special power saving mechanisms and power management functions to all the wireless devices. And license free operation. So, LAN operators do not want to apply for a special license to be able to use the product. If we buy a new wireless device for local communication, local data communication, and if the rules are insisting us to get the license and all, then definitely we will reject to use the devices. So, that kind of purchasing the license for a local data communication should not be forced by the providers. So, that has to be taken care by the designers and the service providers. So, the equipment must operate in the license free band such as 2.4 GHz ISM band. 2.4 GHz ISM band is used worldwide for majority of the wireless LANs. The next design goal is about the robust transmission technology. As the WLANs use the radio transmission, many other electrical devices can interfere with them. For example, vacuum cleaners, hair dryers and train engines can interfere with the wireless local area network signals. We should design the robust transmission technology to withstand with the all kind of interference issues. Let us have a short break. Let us continue our discussion after the break. Welcome back. Before the break, we were discussing about the design goals of the wireless LANs. Let us start our discussion from the remaining design goals of the WLANs. So, the next design goal is simplified spontaneous cooperation. The wireless LAN devices should ensure that the spontaneous cooperation with the existing network. It should not need any complex procedures to boot up the devices. So, that kind of automatic or spontaneous booting of the system should be ensured. The next design goal is easy to use. So, wireless LANs are made for simple use. So, they should not require any complex management rather than plug and play basis. The next main design goal is protection of the investment. We know that already in many institutions and campuses and many higher offices and all, we have already built up the wired LANs. So, we cannot just like that ignore all the wired network. So, now the wireless LAN devices should be able to interoperate with the existing infrastructure. So, that is the main aim. So, any wireless local area network designers should ensure that their products are able to communicate with the existing network. A lot of money has already been invested in the wired network. So, the new wireless LANs should protect this investment by providing the better interoperability with the existing network. Bridging is the concept that is used to bridge the wireless LANs to the existing wired LANs. So, almost majority of the wireless LAN devices are able to provide such kind of bridging support. So, as I already mentioned, the safety and security is the main goal of the wireless LAN device. So, wireless LANs should be safe to operate, especially regarding low radiation. In hospitals and all, doctors may use the wireless LANs, and even the patients can use the wireless LANs to state their status to the doctors and other management people. But the wireless LAN devices should ensure the low radiation, as the high radiation may affect the persons in the hospitals. Users cannot keep safety distance to the antennas. So, the equipment has to be safe for pacemakers also. So, users should not be able to read personal data during the transmission. The main goal of the WLAN is to ensure the security. Even the malicious or valid users, they should not be able to read the data while the data is in the air medium. So, that kind of encryption, decryption mechanisms should be provided to ensure the network security. The network should also take into account the user's privacy. It should not be possible to collect the roaming profiles for tracking the persons if they do not agree. Any user should not be able to track other users in the wireless LAN, but in case of government officials, for extreme cases, they will always use to track the users. So, except that situations, the other users should not be able to track the profile of the other users in the network. Transparency for applications. A good wireless LAN device technology should provide the transparency. So, the user should not feel that their mobility. So, if the user is moving from one location to another location, the services provided to the user should not be disturbed. So, even though the users are in movement, the granted services should not be disturbed to the users. So, that kind of mobility support should be provided by the WLAN. And if the user from the wired network is accessing some information from the wireless part, then the user of the wired part should not be feel that they are accessing the information from the wireless part. So, such kind of transparency should always ensured in the design of the WLAN. So far we have learned about the design goals of the WLAN. Now, let us start our discussion about the two type of settings in case of WLAN. So, now we know what is a WLAN and we know the advantages and disadvantages of the wireless local area network and how to design a WLAN for providing the better quality of service with the good safety and security mechanisms. The WLAN can be constructed using the two methodologies. They are infrastructure based WLANs and the second one is ad hoc based WLAN. Let us start our discussion from the infrastructure based WLAN. Many wireless local area networks of today need an infrastructure network. So, infrastructure networks not only provide the access to other networks, but they also include forwarding functions, medium access control also. So, the best example of the WLAN with the infrastructure based network is the Wi-Fi. So, in the Wi-Fi, the existing wired network facility can be extended to the wireless users. For example, in a college campus, the existing network, the wired network part can be extended to the students and the staffs with the wireless communication. So, using the access point, the students and staffs will be able to get the internet connection and they can download some files from their university server. So, still all the network facilities are possible with the wireless communication also. So, in the infrastructure network, the communication takes place only between the wireless nodes and the access point. We should understand about the concept of access point. So, in the infrastructure based wireless LANs, we have an equipment called access point. So, now the access point is connected with the wireless users and in one side the access point is connected with the wired network. So, the access point is a device that extends that wired network to the wireless users, that is the standard definition for the access point. So, here the communication is not directly happening between the wireless nodes. In the infrastructure based network, the communication is not directly between two wireless users. If a particular person, a particular wireless user wants to make some communicate with the other user, then the two persons cannot make their communication between them. All the communication should be established through the access point. That is the basic concept behind the infrastructure based WLAN. The access point does not just control the medium access, but also act as the bridge to other wireless or wireless network. Now, the access point can connect to two kind of wireless networks also. So, wireless network 1 that may follow some other standard and some other wireless LAN they can follow some other different standards. Now, a single access point can connect to two kind of wireless local area networks. In some other situations, a access point can connect the wireless users with the wired local area network. For example, IEEE 802.3 is the Ethernet network. Now, that Ethernet network can be connected with the wireless users. Several wireless networks may form one logical wireless network with the help of access point. So, the access points together with the fixed network in between can connect several wireless networks to form a larger network beyond the actual radio coverage. Individual access point has its own transmission range. So, using multiple access points, the overall network range of the entire logical network can be extended to majority of the users. This is a diagram about the infrastructure based WLAN. Here AP is nothing but the access point. Now, the access point is connected with the wired network. Now, this wired network is connected. So, two type of wired network we have. This line says that this is a wired network. Now, three access points are connected with the standard wired network. Now, this wired network may be the IEEE 802.3. Now, this access point provides or extends the wired network to the users within this range. Now, the access point extends the facility to the users roaming in this area. So, like that, now the wired network is extended to many wireless users through the radio communication. So, here the wired network is involved. So, the backbone network is used and it is referred as the infrastructure based WLAN. The design of infrastructure based wireless network is very simple because most of the network functionality lies within the access point, whereas the wireless clients can remain quite simple. So, in case of infrastructure based WLAN, majority of the communication headaches are put on the access point. Now, access point will take care about the collision problem in the network. So, they will control all the medium access mechanisms. So, we know that all the users has to be allocated with some time slots. So, as usual in the wired network, the access point takes care about the medium access control. So, when it should provide the channel to the wireless user 1 and how can it get the information from some other users. So, the medium access control mechanisms are built over the access point. This structure remains the switched ether network or star based network, where a central element or a switch controls the network flow. In case of wired local area network, we have the switches and some other network routers. That switches will control the overall operation of the network flow. So, this type of network can use different access schemes with or without collision. Collision is a major problem in the wireless access. So, in general the IEEE 802.3 uses collision detection mechanism. So, collision detection is nothing but in the standard wired network, all the devices are connected to a same wire. So, all the other devices are able to measure the voltage level, so that they can take a decision whether the medium is busy or not. So, based on that they can wait or they can immediately transmit the data. So, that kind of collision detection is not at all possible always in the wireless domain, because we have the hidden terminal as well as exposed terminal, near and far terminal problems in the wireless networks. So, that has to be taken into account while designing the wireless local area network. Collisions may occur if the medium axis of the wireless nodes and the access point is not coordinate. So, the access point has to take care of all the medium access control mechanisms. So, else the collision detection will happen and the data loss will be very high. The access point may poll the single wireless nodes to ensure the data rate, as well as the infrastructure based networks lose some of the flexibility wireless networks can offer. Example, they cannot be used for disaster relief in cases where no infrastructure is left. Any severe disaster management is happening and all the infrastructure is lost, then the infrastructure based WLAN will be failed, because once again you have to build up all the access point and you have to get the standard backbone network to build up the entire network. But in case of ADAC network, immediately the network can be set up. So, immediately all the devices will boot up and they will form their own local network. So, the infrastructure based WLAN also has its own demerits. So, typical cell phone network or the infrastructure based network for a wide area. So, the best example for the infrastructure based WLAN is the cell phone communication. So, in the previous lectures we have learned about the global system for mobile communication, that is GSM. In the GSM we have the tower is connected with the GSM backbone network, and in one end the mobile users or the cell phone users are connected with the cell phone tower through the wireless signals. So, now the tower is equivalent to the access point in the WLAN. The users are making the call to the tower. So, just like that the users are making the communication with the access point. So, in the tower all the medium access control protocols are implemented, as well as in the WLAN the access point takes care about the coordination to avoid the collisions. And satellite based cell phone communications are the another example for the infrastructure based WLANs. Infrastructure does not necessarily imply a wired fixed network. So, the users should not confuse the infrastructure or the meaning of the infrastructure. Infrastructure does not only imply the complete or 100% use of the backbone network, it may involve some of the wireless parts also. Let us summarize what we have discussed. The goals of the WLANs are to replace the office cabling, to enable the access to the internet, to introduce a higher flexibility. The existing wired applications should continue to run over the wireless local area networks. The new wireless local area networks should protect the investment by being interoperate with the existing wired networks. Let us pose some questions for our understanding. What are the design challenges of the WLAN? How does the WLAN support mobility? Identify the counterpart of an access point in the wired LAN. Can we connect a WLAN to the wired LAN? Differentiate collision detection and collision avoidance. With this we conclude our today's lecture. In the forthcoming lectures we will learn about the ad hoc based wireless LANs. Thank you.